Hey guys, this is Mrs. Wagner. I'm going to go through a couple things with you that are going to help us review Activity 58 and then get started on Activity 59. So we've already kind of done a review of the whole Sky and Poppy story, but what we're going to talk about is how we're going to model Hypothesis C, which is the one that most of you chose, which was that you get half of your information from your mom and half from your dad. So to model this, we're going to talk about a couple things like the term allele is important here. So we're going to talk a little bit about how we would set up alleles in this situation to make it work. I'm going to open my bag here. Okay, so a couple of things that are important to know to start with is that you need to have two alleles for every gene. You have two alleles because you get an allele from your mom and you get an allele from your dad. So Sky over here, he is purebred. He has had the same genes for many, many, many generations. So the two alleles he's going to have, he probably got a blue-tailed gene from his dad's sperm cell and a blue-tailed allele, from his mom's egg cell because he's had the tail-colored gene for many generations in his family. Poppy, same idea, except she's the orange-tailed critter, so she is going to get an orange allele from her mom and an orange allele from her dad's sperm cell. Now, in order to pass alleles on to your offspring, remember that Sky is not really losing alleles. Poppy's not going to lose the allele she already has. But we know that Sky and Poppy are producing egg and sperm cells. That's how they're reproducing. And because Sky has two blue alleles to begin with, this is the only allele Sky can pass on in his sperm cells. So Sky is going to, in his sperm cells, he's only got the one option. He's going to pass on a blue allele to all of his offspring. Poppy also has only the same kind of allele, so she's going to pass an orange allele on to all of her offspring as well. Now what we notice is that Ocean and Lucy, they each have two different types of alleles. They have an orange and a blue allele. We only see on the outside, though, that they have this blue tail color, and that's where the word dominant comes into play. In this situation, blue is dominant over orange. If I were going to represent this with letters, I would use an uppercase letter to represent the blue allele and a lowercase letter to represent the orange allele, like a big T, little t. They have one of each. But dominant says only the blue one shows, even though both of them is there. Now, when Ocean and Lucy pass on their alleles to their next generation too, here's where the coin toss becomes a little bit more important. We are tossing coins because one of you is going to be Ocean and one of you is going to be Lucy. And you'll know that there's obviously two different sides to the coins. And that's because Ocean has two different alleles that Ocean could possibly pass on to their offspring. Lucy also has two different alleles. Heads is going to be the blue allele or the dominant allele. And tails is going to be the orange allele or what we call the recessive allele. We don't know which of the two they're going to pass on. Here's where the probability comes in. Now, if we look at the possible outcomes of what could happen, though, if we look at my situation, Ocean could give a blue allele in the sperm cell, and Lucy could give a blue allele in the egg cell. So one possible combination is that an offspring could get one of those, one each. Another possible combination would be Ocean could give a blue, and Lucy could give an orange allele. So that's another possible combination. Third possible combination, Ocean could give orange, Lucy could give blue. So that's my next possible combination there. And my last possible combination is that Ocean and Lucy could each give an orange allele, leaving this offspring as orange. So this is how we ended up with this 3/4 blue, 1/4 orange kind of situation. This is what we consider to be like skipping a generation, right? Ocean and Lucy still have the orange allele. We just don't see it physically. It's in their genetic makeup, but it's not something we see physically. And this is why down here, remember, these guys are still blue because blue is dominant. 3/4 blue, 1/4 orange. That's what you guys are going to be modeling today in your coin toss. I'm going to show you that in just a second. So you have to find someone who's going to play the role of Ocean and someone who's going to play the role of Lucy. That'd be my daughter, Leah. Hi, Leah. All right, and you can just do this on your own if you want. But remember that you are representing Ocean and Lucy. we are going to flip to determine what alleles they pass on. So you're going to flip your coins. Okay. I got tails and she got heads. And so based on this, I'm going to use letters to represent our alleles. So tails is going to be your orange allele and heads is going to be your blue allele. So we've already done a few practice, but so what she's going to write down for each offspring. So I'm Ocean and I have tails. So she's going to write a lowercase letter here because tails is recessive, or the one that gets covered up. We use lowercase letters for that. She got heads, so she has a blue allele. Blue alleles are capital letters. We use the same kind of letter for each gene though. You put those two alleles together and that's going to make your offspring. So those two alleles combined, an orange and a blue. Remember, if you have an orange and a blue, the blue still wins. The dominant one wins. It's going to be blue. Okay, we'll flip for you one more time just to show you, but you can do this by yourself if you want. We're going to flip our coins again. I got tails and she got tails. Okay, so we both are passing on an orange allele. So the orange alleles are the little letters. You got a little letter. And put those two alleles together because that's going to represent which one of your offspring down here. We each gave an orange allele in that case. And so if I have two orange alleles, I know I'm going to be orange. So you guys are going to do this activity and you're going to work your way all the way through lots of data. Then you're just going to count up how many orange and blue you ended up with, and you're going to put that in the spreadsheet that I gave you. One last little note just about ratios versus fractions over here. We can easily represent that over here. If we're talking about a ratio, we are talking about, comparing one group to another group. So I'm going to ask you to figure out ratios. It's just counting up how many blue you have compared to how many orange you have. Essentially, you're going to divide those two. So like if I look over here at what I got in this activity here, I have 3 blue and 1 orange. So it's like taking a 3 divided by 1, and I get 3. And then you just put your 3 to 1. That's a 3 to 1 ratio of how many blue parts per orange part. To make a quick flip from a ratio into a fraction, remember fractions, on the bottom of your fraction, your denominator is the total number you have. So if I look back over here, I have 3 blue and I have only 1 orange, but I have 4 parts total. So out of the 4 parts, 3 of them are blue. So 3 out of 4 are blue and 1 out of 4 are orange, just like that. And if you have your ratio already figured out, you can just, it's 3 parts to 1 part. If you add them up, there's 4 total parts. That's going to be the denominator of your fraction. It's just 2 different ways to show you a particular outcome of an experiment. Okay, guys, good luck. If you have any questions, let me know, but make sure you get your data in today so that we can use your data tomorrow in helping us collect class information. Have a good day. Say bye, Leah.